So, hey, welcome to Time is on Your Side, an introduction. Oh, let me share my video too. It's such a beautiful day outside. I actually have some decent lighting for once. Welcome to Time is on Your Side, an introduction to time intelligence inside of DAX. Or another way you might want to think of this presentation, or the name we might give it, is Fun with Fixed Width Fonts. So if you're a giant fan of fixed width fonts, oh my goodness, you are going to absolutely love this presentation. If you hate fixed width fonts, you may want to find something else to do with your afternoon. That said, let's dig into it, shall we? Assuming PowerPoint will let me. Hold on, PowerPoint. There we go. I'm Brian Grant, for folks that don't know me. It says I have expertise on this slide. I don't know if I quite say that. I'm pretty good at DAX. I'm pretty good at M. I'm pretty good at data modeling, and I'm pretty good at data visualization. There's a lot of things I'm pretty good at. I'm also the creator of the Elements of DAX series, which is something we're going to kind of be referring to throughout the rest of the course of this video. If you want to learn DAX, I think this is sort of the middle step for DAX. So if you've worked through some of the sort of thinner books, and they're really great books, and you've enjoyed them, and you've looked at the SQL BI books that are a little bit thicker, a little bit harder, and you're wondering, is there something in the middle? This video series is for you, so check it out. You'll learn a lot about DAX. We're going to create a good conceptual framework for you. Okay, enough sales speak. Yeah, I train a lot of people. It's a lot of fun. Okay, so time intelligence. I am sorry, you simply have to learn it. Even if you don't want to, you don't really have a choice. The thing is, I find, in my experience, most companies do tend to exist within a four-dimensional space-time continuum, which is to say every company deals with time. Because every company deals with time, these time-based calculations are going to be sort of the first thing you're always going to be asked to do. So you kind of have to learn how to do them, regardless of whether what company you work for. If you make bumpers for a car, if you make Ritz crackers, if you make space shuttles, doesn't matter. Time intelligence is something you're always going to have to do. Okay, so you may notice, if you're fairly new to Power BI, fairly new to DAX, that there are these pre-built time intelligence functions that Microsoft provides for you. And I don't want to be too dismissive of them. There's nice things about it, right? They're going to do a lot of work for you. However, there's two sort of problems you're going to deal with these. Number one, they don't work. Not always, not all the time, but they don't consistently work, right? These functions are going to require assumptions to be true about your data, which sometimes will be true and other times will not. Now, if you happen to know what all the assumptions are, okay, that's fine. You know when it's safe to use them and when they don't. By the time you have that information, you already know how to build your own, and you don't really need these things, right? Also, even if the assumptions hold true about your organization, you will often find with these built-in time intelligence functions that the subtotals look kind of funny. It produces weird numbers, which takes us to problem number 2. You cannot explain how these things work or how they don't work, right? So if you create a visual and you use one of these built-in time intelligence functions, like, you know, dates quarter to date or same period last year, something like that, they work pretty good for the months, they work pretty good for the days, and then you get it to the year and it produces a number and no one can quite figure out why it's even showing a number. And your boss looks at you and says, where does that number come from? And your answer is, I have no idea. So if you're okay with that, fine. You don't have to watch the rest of this presentation. I find, though, if you're going to be even semi-serious about DAX, you're going to have to learn how to do these things on your own. Because if you want to fix it, you have to be able to see inside of it. And you simply cannot do that with the built-in time intelligence functions. Right? I'm going to hold on questions till the end, just because I'm going to get a flow going. But please post them in there. We'll keep track of them. I do want to answer them. Okay, so what else am I going to talk about? Oh, yeah, DAX. DAX, what we're here to talk about. DAX is a language that thinks in tables, right? And so should you, right? So the thing about time intelligence, in addition to you sort of have to learn how to do it anyways, or you have to at least do it. It's a good idea to learn how to do it. It is an excellent way to learn how to think in tables. Because DAX is a language that thinks this way, if you can converse in tables, you'll be able to converse with the DAX engine. Okay. So what I'm going to be doing today is I'm certainly going to be showing you some examples of time intelligence formulas, but more importantly, I'm going to be showing you how they actually work step by step inside of DAX. And hopefully in seeing that, you'll get a sense of how time intelligence works. But maybe more importantly, you'll get a sense how DAX works and thinks in general. And you'll see just how simple and repetitive the language actually is. It's not intuitive, but it is simple. Okay, so speaking of simple, hey, I'm a simple man, and I'm going to work with a very simple model here. We're going to have not one, but two tables, two big, complicated tables. we're going to have one called dim quarter and one called fact sales, right? So fact sales is going to have all of our sales transactions. For every single transaction, we're going to have the price of each transaction, whether it was $8,000 per unit or $4,000 per unit, and also the quantity, whether somebody bought 4 of them or 2 of them. Now, you may be saying to yourself, Brian, I don't think this company is going to stay in business very long. Yeah, I know. I'm keeping things kind of simple for the demo. Just kind of go with me, okay? So for each sales transaction, we've got the price and the quantity. We also have the quarter that it happened in, which is going to take us here to our dim quarter table, right? So normally in real life, you would have a dates table because usually you'd be more interested in the date that something happened than the quarter something that happened. That's right, simple but not easy. However, because I want to squeeze everything visually onto the page, I'm going to roll everything up to the quarter, right? Which is going to make it a lot easier for us to look at and hence, therefore, understand. So if you're brand new to Power BI, you may be surprised that these are separate tables. This isn't a presentation on dimensional modeling, but I'll simply say that within DAX, it's usually best practice to take your data tables, the ones that have the numbers. We'd call these fact tables. You'd store them in a separate table from the tables that have the categories, the things that we're going to want to slice and dice by. These are something we call dimension tables, which is where you get the dim and the fact on top of it right there. Okay, right? So we've got our dim quarter table, we've got our fact sales table, and of course, we're going to have a relationship between these tables. So in Power BI, you'll go to this third little button right here, and if there's not automatically a relationship, you just drag that column under that column. And what this means for us is that when we have this relationship in place, if we have a slicer, an ability for a user to slice down their data, and they click on something like 2017, well, that filter will filter down the year column in dim quarter to filter down to just 2017, which filters down to these 1, 2, 3, 4 quarters, which will then pass down to the fact sales table, so that in fact sales, it'll only be these transactions that are visible. So if we go calculate total sales, we'll just see the ones for 2017. That's how relationships work. Pretty similar to a VLOOKUP in Excel or a left outer join in SQL, if that's how you want to think about it. Okay. So I will also point out that in the dim quarter table, you will notice there's a quarter column, but then there's this sort of curious quarter number column, right? Having a column like this where you've got an incrementing value where it goes up by 1 every single row, that's going to be super duper important for time intelligence. Now, in this very simple model, we've only got years and quarters, and so we have an incrementing number for each one of these guys. Years increment themselves and the quarters increment themselves. If we were to do a bigger class where we had months and weeks and things like that, well, for the months and weeks, we would also have to have a column that has the month as an incrementing number and the week as an incrementing number. This allows us to do things like figure out which week or month or quarter or year we're in and subtract 1 or add 1 if we want to go backwards or if we want to go forwards, right? Okay, so. With that said, I do want to point out that in this presentation, I'm going to be using some fancy DAX to redraw my tables with a fixed width font. So in the presentation, I'm going to have something that looks like the dim quarter table, but it's actually going to look like this. This is me using DAX to draw the dim quarters in the presentation. Similarly, for the fact sales table, where we've got all of our sales transactions, well, I'm going to draw it, and it's going to look like this, right? So I know they look a little different. That doesn't look like that. That doesn't look like that. These are representations of both the dim quarter table and the fact sales table. Okay. All right. So I said before I'm a simple man, and in addition to a simple model, I have a simple plan. My simple plan just has three big phases, right? In all of my time intelligence measures, right, we're going to gather some hints. We're going to use them to filter down to a table of quarters that we want to look at. And then we're going to use that table as a filter and then go calculate total sales, right? So for example, let's say that a user selected 2017. Well, in this section, I'm just going to need the one hint. So here in the first section, I'll go figure out what the current year is that's selected. Oh, it's 2017. Then I'll subtract 1 to get 2016 if I wanted to look at the previous year. If I wanted to look at the next year, instead of subtracting 1, I would add 1. But we want to look at the previous year. So let's imagine we clicked on 2017. We want to see previous year sales. We get the current year. We subtract 1, and we get 2016. With that number, that hint right there, we're then going to go to the next section where we build a table with all the quarters in 2016, because this is just a number. I can't use this as a filter. In DAX, tables are filters. Filters are tables, right? So in the next section, what we'll do is we'll use this number to build a table that just has all the quarters in 2016. Then once we got that table, right, in the very last section, we'll take this table, we'll use the calculate function to add it as a filter, and then we'll go calculate sales for not the 2017 quarters, but the 2016 quarters. Okay, that's going to be our plan. Now, for the first couple, we're just going to need one hint. In some of the later examples, we might have multiple hints if we get that far. Okay. Now, I want to point out within these sections here, hint one, filter, and return, you'll see this derive, iterate, adjust kind of stuff. Now, if you're unfamiliar with my elements of DAX series, part of what I'm doing there is I'm taking very similar kinds of operations in DAX, and I'm sort of classifying them. I'm giving them a taxonomy. That way, within a bit of DAX code, if you have several bits of it that do the same kind of thing, you have a name for them, right? So similarly, we're going to have the same kind of operation each one of these sections. In each one of them, we're going to derive. Derive is creating a temp table based on the data, based on the tables in the data model. We're also going to iterate in each one. Iterate there, and iterate there. Iteration is basically taking a table and processing it down into a new value, maybe a number, maybe a new table, right? And the last bit is revise, right? Revise, we're only going to do that once, right? Revising is all about taking the temp table that you've made and adding it as a filter, right, to change which bits of the data you're looking at, okay? So part of my goal in this presentation is to make it clear just how repetitive the DAX language is. And I know I've said that before, but if you'll remember back then when I said it, part of my goal is to make it clear just how repetitive this is, which is why I'm repeating myself right now. Okay. So what's this going to look like a bit more mechanically, right? So imagine we've got 2017 selected, right? In the code, say total sales for the previous year. This is a simplified version of it, right? In this section right here, this is hint number one. We're going to go figure out what the current year is, right? And then we're going to subtract one. So if 2017 is selected, we're going to get the current year 2017, subtract one, which will give us 2016 right there. Here in the next section, we're going to take that number and build a table of quarters that are all the quarters in that year or month or whatever it is, 2016. Then here in the last section, right, we're going to take this table, we're going to add it as a filter, and then we're going to use that filter to calculate total sales looking at the previous year. Okay. So, enough preamble. Let's go ahead and get started, shall we? So I'm going to go ahead and pull this over, and I am going to see if I can figure out how to use Power BI service. Okay. So if people cannot see my screen, please holler. That would be a problem. So what we've got right here is some code. This code right here is the code for a previous year simplified measure, right? So this is total sales for the previous year, right? In a minute, I can show you some other examples where we're looking at the following year or the previous month or the following month, but we're going to start out with the previous year calculation, right? And if you'll notice, as I click through these, you can see that little bits change over here, but the overall pattern stays very, very consistent, okay? So let's just start with the previous year, okay? So we're going to look at previous year sales. And by the way, the number is 107,000, if you were curious, right? So, and if you look down here, we've got 8 quarters of data, and we're just looking at 2017. So if we're getting previous year sales, and we've got 2017 selected, we should be getting sales for 2016. Okay, good. So in addition, you will probably also notice we've got the code here. Over here, we have the data model, our tables of data, right? And you can see we've got the dim quarters table and we've got the fact sales table. And you can see that only some of the rows are visible, right? So right now, because I've got 2017 selected, you're only looking at 2017 rows. If I were to click on, say, 2016, well, then we'd be looking at 2016 rows. If I were to click on Q2 of 2017, you'd only see Q2 of 2017, et cetera, okay? So I'm going to pop back to looking at 2017. Okay, these are all the visible rows based on the filters that we have in place. Speaking of filters being in place, did you notice when I clicked on 2017, this down here changed? This is the filter context, if you've heard that term before. These are all the filters that are currently in place. And when I click on the slicer here, it's going to add a filter that looks like this. Like I said before, in DAX, filters are tables. So when I click on 2016, it's going to add a table that has the year and the values for 2016 and the quarter, this Q1, Q2, Q3, and Q4. So quarters 1, 2, 3, and 4 for 2016. If I were to click on, I don't know, Q2 and then control click on Q3 of 2017, well then we'd have a filter for just Q2 and Q3 of 2017. Okay, so these are the filters that are currently in place. This is what the data model looks like with those filters in place, where you could just see the visible rows, right? And here's the code we're going to run through, right? By the way, here's those sections that we saw a minute ago. Okay, so to make this work, I'm going to go ahead and click on all of 2017. It's going to make it work best. And now I'm going to press this play button and then immediately press pause. And by immediately, I mean right about now. It takes a second to get going. Okay, so the very first thing that happens in the measure is the measure is going to start evaluating, okay? So because we're doing this in a card, right, the filters for the slicer are already in place. Now, if we were doing this measure in a table, right, or a matrix or something like that, the very next thing it would do would be to add any values of the current row as a filter, right? So if we were taking total sales by quarter, you'd have one calculation per row, and it would add each row's quarter as a filter. But because we're doing this in the card, we can kind of skip that part, okay? So now the filters are all in place. We've just got the one filter from the slicer over here for all of 2017. Now the measure can start evaluating its sub-expression, right? Its formula, right? This stuff down here. Okay, so what are we going to do? Well, we're going to get some hints about what the new year we want to look at is. We're going to use those hints to get a new a new table that has all the quarters in that year, and then we'll use to calculate sales. So let's start with a hint, because that's kind of the easy part, okay? So where it says VAR right here, that's a variable. We're going to go run some formula and then stick the results in a variable so we can call it up later. So when we have this variable, which is called VR hint underscore new, VR just standing for variable, the very first thing that's going to happen in there is this bit right here, right? So MaxX is an iterator. You may have heard of those before. They take a temp table, add a column to it, and then do something with the results. So the very first thing that happens is we have to give it a table, right? And here's how we're going to give it a table. So there on that row where it says dim quarter, basically what we're asking Power BI is, or more specifically the DAX engine is, go get me all the visible rows of dim quarter. Not all the rows of dim quarter, just the visible ones. And because we have this filter in place, the only visible rows, the only visible quarters are the ones in 2017. Makes sense. We got 2017 selected. So when I go to the next step, this is going to turn into a table. In fact, it's going to turn into that table right there, which is all the rows of 2017, right? So let me go back just so you can see it again. Right, that bit right there where we ask for dim quarter goes and gets all the visible rows of dim quarter as a temp table. This is a temporary table that just exists sort of within the formula, okay? So now that we've got that temp table, we need to do something with it. That's where the iterator comes in. So the iterator is going to say, I'm the MaxX iterator. You've given me this temp table right here. Argument 2 is the definition of the column that I'm going to add to it. So for every single row, I'm going to have a new column where for every single row I get the year. So it should say 2017, 2017, 2017, 2017. And in fact, when I click to the next step, sure enough, that's what we get, right? So we have a new column with the values 2017 all the way down, because that's the formula that we've got right there, the formula for each and every cell of that new column. Now, I like to call this the expression column because it's based on that expression right there, but it doesn't really have a name because it's not going to be around long enough to bother naming it, okay? So now that we've added this column, the next thing we're going to do is we're going to turn it into a new value. Now, if you will notice, the name of this function is maxx. That gives you a hint as to what it's going to do with the column. If it were minx, it'd take the smallest value. If it were sumx, it would add up all the values. If it were averagex, it would average the values. But this being maxx, it's going to find the biggest value. Now, who's good at math? Who's really good at math? Anybody happen to know the biggest number in this column right here? 2017, 2017, 2017, 2017? Yeah, that's right. You guessed it. It's 2017. There we go. So that's going to return 2017 right there. Now, 2017 is the current year we have selected. This is supposed to be a previous year calculation. That is where our adjustment comes in. So we take that 2017 and we're going to subtract 1 right there. And again, who's good at math? 2017 minus 1 is 2016. Okay. So that is going to end up being our hint. And the next thing that's going to happen is now that we've got that number, the DAX engine is going to stick it in that variable right there so we can call it up in just a minute. All right, so it's going to look like that. There we go. So now 2016 is stored in the variable VR hint new year. This is going to be the new year that we want to look at. Okay, we've got our hint, right? Now we could use that hint to build a new table of quarters, which are going to be all the quarters in 2016. So let's go do that. I'm going to pop forward, right? So we're going to start evaluating this next variable. This one's called override new quarters. This is going to be a table that we use to override the filter. Say stop looking at 2017, look at 2016 instead. And it's going to be very similar to what we had up here a minute ago, right? Just like before, we're going to start with the derivation, right? This right here is a derivation. Now, before, we asked for dim quarter, just DIMQTR, which gave us all the visible rows in dim quarter, which were just these 4 right here because we've got 2017 selected. Because we've wrapped this in the all function, that is a different derivation. It's still going to produce a temp table based on this table in the data model, but unlike the one above, it's going to show all the rows, which is why they called the function all, which is a pretty good name for it, right? So we're not going to get 1, 2, 3, 4. We're going to get 1, 2, 3, 4, 5, 6, 7, 8. In fact, it's going to look a whole lot like that. Hey, there we go. There's all the quarters, not some of them, all of them. So I go back. So all dim quarter produces all the rows in dim quarter. Okay, so that derivation produced that temp table, which we then give to the filter iterator. Hey, weren't we using an iterator just a second ago? That's right. A second ago, we were using the maxx iterator. Now we're going to use the filter iterator. Just like the other iterator, it's going to add a column to this table and do something with the result. And just like the SUMX iterator, the definition of the column is going to be argument number 2. So let's go look at argument number 2. So what are we going to say? What's the definition of this new expression column? For every single row, check to see if that row's year is equal to the VR hint new year. Let's replace this VR hint new year with the actual number. If you'll remember, it's 2016. Let's go ahead and add that. So we're going to turn that to 2016. So really what we're saying is, for every single row, check to see if that row's year is equal to 2016, right? So it's going to check that row, that row, that row, that row, that row, all the way down. And it's going to produce a column that looks like this. There we go. So now, for every single row, we see if that row's year is equal to 2016. 2016 is indeed equal to 2016, and as you might expect, it's true for quarters 1, 2, 3, and 4 of 2016. But then when we get into 2017, well, 2017 doesn't equal 2016, so we get falses all the way down. Okay. Now, the next bit is the iterator has to process this expression column, do something with it, create a new value based off of it. Okay. So before, with the maxx, we got the biggest value. If it was minx, we get the smallest value. If it was sumx, which we'll do in a second, we'd get the sum of the values. The filter function, which should really be called keep rows x, is going to keep the true rows, right? It's not going to produce a number, it's going to produce a table. So in a second, when I press the forward button, we're going to get all of the true rows, which should be 1, 2, 3, 4 of them. In fact, it'll look like that right there. Hey, there we go, okay? That's how we turned the number 2016 that we got from our hint into a table of all the quarters that we want to look at, okay? So what do we need to do next? Well, we've got the table of all of our quarters, right? Next thing we have to do is we're going to store that in the variable because we're going to use it in just a minute, okay? So now that temp table right there is stored in the VR override new quarters variable. So we can call it up right about down here. Okay, good. So we've gotten our hint, 2016. We've used that numeric hint to produce a table of all the quarters we want to look at. Notice right now in the filter context, we've got a filter that's looking at 2017. What we want to do is we want to override the filters with this temp table right here, which is what we're going to do in a second with the calculate function. You guessed it. You guessed it. Okay, so last bit, home stretch. The calculate function says, well, the purpose of the calculate function is to run a sub expression, run some bit of code after you change the filters. After you change the filters, right? So argument 1 is the thing that we're going to run after we change the filters. So counterintuitively, the first argument is the last thing that runs. That's kind of hard to wrap your head around, okay? So if that's the last thing that runs, well, what's the first thing that runs? All the different ways that we're going to change the filters, right? Specifically, we're going to add a filter based off of this right here, which is VR override new quarters. Oh yeah, that's this right here. That variable that has that temp table, this is going to be our new override, right? So I'm going to pop this out. Hey, there we go. It called up the results from that variable. And now the calculate function is going to stick that in the filter context. And when it does, it's going to look like that. There we go. Check it out. The filter context now has this new table. The temp table that was sitting up here, calculate, has shoved it into the filter context, right? And notice this filter up here is blacked out because it is disabled. Let me go back a step. If you'll notice, the old filter had a filter for year and quarter. When we add the new filter, it says, well, if there's a disagreement, because this filter also has year and quarter, we assume that the new quarter wins, which is why this one is disabled, just temporarily, okay? Did you also notice, I'm guessing you didn't, I wouldn't have expected you to, did you also notice that up here, all the visible rows in the data model just changed, right? Let me go back a second. So a second ago, before calculate added that filter, we were looking at 2017. We were looking at all the quarters for 2017 and all of the sales transactions for 2017. When I move forward, right, we add that filter, right? Now we're looking at 2016 down here, and sure enough, up in the data model, we're also looking at 2016. These are all the quarters for 2016 and all of the sales transactions for 2016. So even though the user has sliced down to 2017, as far as the data model is concerned, these are the rows that are visible, the rows for the previous years, which is going to be handy if we've got a calculation called total sales previous year, right? Okay, so we've added that to the filter context. Now, calculate says, all right, good. I'm done adding the filters, done revising the filters. I could go ahead and run that sub-expression, that formula in argument 1. Well, what's in there? Same as above, right? Up here, we had a derivation inside of an iterator. Up here, we had a derivation inside of an iterator. Down here, what do we have? Of course, we have a derivation inside of an iterator, right? Okay, so the derivation is fact sales. Let me go sort of focus on that, right? So before, when we asked for dim quarter, we get all the visible rows of dim quarter. And sure enough, when we ask for fact sales, we're going to get all the visible rows of fact sales. Not all of the rows of fact sales, just the visible ones, the ones in these quarters right here, right? If we change this derivation and wrap an all function around it, we'd get all of them, but that's not what we want. We just want the ones that are visible. We just want the ones for last year. So when we go to the next step, that fact sales turns into all of these sales transactions in 2016. There they are right there, okay? So that's our derivation. We got a temp table from the data model based on the current filters. Right? And now the iterator, SumX, is going to do two things. It's going to add a column to the table based on this formula right here, and it's going to sum it up because it's a SumX iterator. Okay, so pop on forward. Here's the definition of our new expression column that we're going to add. SumX goes ahead and adds it. Column doesn't really have a name. I like to call it the expression column, right? And so sure enough, what do? For every single row, we take that row's quantity and we multiply it by the price. So 4 times 8,000 is 32,000. 2 times 4,000 is 8,000. 4 times 8,000 is 32,000. And you kind of see how the rest of it goes, okay? So this is our new column based on that expression right there, that formula. So what do we do with it? Well, it's the SumX iterator. So once it adds the column based on that definition, it's going to sum it up. It's going to sum it up. So we take SumX iterator, goes ahead and sums it up, and what do we get? 107,000, which, by the way, happens to be total sales for 2016, right? Now, you may be thinking to yourself, hey, why doesn't it say 107,000 up there? Well, that's because we're not quite done yet. This is indeed going to be the answer, but Calculate has to do a little bit of housekeeping first. So a second ago, Calculate added this filter to the filter context so we could get total sales for the previous year. Calculate, being a good roommate, is before it returns a number, it's going to go clean up the filters, right? It's going to go pull that filter out, set the filter context back to the way it found it. Ah, there we go. Notice we've stopped looking at 2016, and now we're looking at 2017 again, just like it says on the slicers. Okay, so now that we're done with that, Calculate can actually return the number. It's going to return the number, which then gets passed to the measure's return keyword, right? And what happens then? Well, this is saying basically that's the actual answer. And in a second, when we're all done, we go to the very last step, and we get 107,000. And that is how DAX got to that 107,000. Okay. I'm going to show you, based on time, I think we might have time for 2 more. In the next example, I'll show you a previous month calculation. I'm going to pause for just a second. Are there any quick questions before we move on to the next example? Going once, going twice. Okay. No? Oh, good. Oh, I'm glad you like it. Okay, so let's go ahead and do a, oh, shoot, I don't know. What do we want to do? Let's just do a previous month calculation. Okay, so let's do this month previous year. That's a bit more interesting. This month previous year. So what I want to do is I want to find a month last year that had a couple different transactions. Ah, good. Q3 of 2016 had a couple different transactions. So what I want to do is I'm going to go look at Q3 of 2017. So we're looking at Q3 of 2017, and the measure is this month previous year. So this should, that 8,000 right there, that should be the transactions for not quarter number 7, but quarter number 3, which is the third quarter in the previous year. Okay, good. All right, so let's go ahead and do that. I'm going to go ahead and reset my little player right here. And we're going to go ahead and get right to it. So I'm going to press play, let it warm up. Hey, there we go. Okay, so when the measure wakes up, the measure will find that the filters from the slicer are already in place. And sure enough, there they are. We've got one filter for Q3 of 2017. There's that filter right there. Now, if we were executing this measure in a table or a matrix or some more complex visual, the very next thing that it would do is it would go look at any values of the current row and add them as filters. However, for simplicity, we're just doing a card right now, so I think this is good enough. Okay. So now, with all the filters in place, and it's just the one filter for Q3 of 2017, we can now go ahead and the measure can go ahead and run its formula. So let's go ahead and start with that. As a reminder, what's our general pattern here, right? We're going to generate a hint, a numeric value that's going to give us a hint about what our new set of quarters is going to be. We're going to use that numeric value to go generate a table with that quarter or those quarters, right? And then with that table, we're going to use the calculate function to add it as a filter and then go calculate total sales, looking at that new slice of time that we want to see. Okay, good. So let's start with a hint, right? So the first thing we're going to do in here, right? We've defined a variable called VR hint new quarter, and it's got this bit of code right here. We're going to go get all the visible quarters, going to temp table all the visible quarters in dim quarter. MaxX iterator is going to add this column to it and find the biggest value, and then we're going to subtract 1. Oh, did we? I think I may have biffed in my profile right here. So why don't we do the easier one that's actually working? Let's go do previous month. That's what I meant to say. This is a previous month calculation. Sorry about that. I thought I got all those bits ironed out. Okay, so is following month working? Let's do previous month. That makes a bit more sense to folks. Okay, so same deal though. Let me go ahead and press backwards and forwards. Okay, so now we're looking for the previous month. So if we're in Q3 of 2017, we want sales for Q2 of 2017. Otherwise, the process is about the same, okay? So now we've got a filter for Q3 2017, just like before. We're going to go get all the visible rows of dim quarter, which is just the one right there. So that dim quarter is going to turn into that temp table right there with one row. It's just that one visible row, right? And then the MaxX iterator is going to say, okay, I'm going to add an expression column to it with that definition, and then take the max of it. Let's go there. That is the definition of our expression column. For every single row, go get that row's quarter number, right? Not the label, but the number, the incrementing number. Okay, good. So we've got one row and one column with 7, right? Okay, so again, who's good at math, right? And we're going to go take the max of that column. Okay, and as you might have guessed, it's the number 7, right? If I did that too fast for you, I apologize, right? So we put 7 right there. It's the one quarter we got. We took the max of it, and then we get 7 back. Now, that is not the quarter we want. That's the quarter we're in. We are in quarter number 7. That's Q3 of 2017 is the label, but the actual number is 7. Remember, it goes 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we take that 7 and we subtract 1 from it to go back a quarter. Okay, so I go back a quarter. There we go. So we subtract 1 and we get the number 6. That's the actual quarter that we want to look at. Okay, that's all well and good, but this is a number. DAX thinks in tables. Remember I told you DAX thinks in tables? If we want to override the filters, we're going to need a table to do it. That's where the next section comes in. Okay. So we're going to store that in the hint or in the variable. So now VR hint new quarter. Well, that's got the number 6 in it. So let's go ahead and start working on getting that table ready. Okay, so we've got a variable called VR override new quarters. These are the new quarters that we want to look at, not the ones we're looking at now, the ones that we want to look at, right? So what do? Well, before we had a derivation inside of an iterator, and here we have a derivation inside of an iterator. Again, we're going to get a temp table, right, with a snippet of code, and then we're going to pass it to an iterator, which is going to add a column to it and do something with the results. Process the results, turn them into a value. Now, before the derivation was just dim quarter, so we got just the visible rows of dim quarter. Well, now we've got all dim quarter, so we're not just going to get the one row. We should get 1, 2, 3, 4, 5, 6, 7, 8. Speaking of which, 1, 2, 3, 4, 5, 6, 7, 8. There's all the rows of dim quarter because we use that all function, right? Let me go back just so you can see it. All the dim quarters. Okay, good. So that is the temp table that all dim quarter produces, that derivation produces. This temp table, though, it's not ready, right? We have to whittle it down to just the rows that we want. Specifically, we should just get the row for Q2 of 2017, which happens to be quarter number 6. So we just want that row right there. How do we do that? Well, that's where the iterator comes in. the iterator is going to take this temp table that the derivation produced. It's going to add a column to it with that definition right there. And it's going to just keep the true rows, right? That's what the filter function does. Should be called keep rows X. Okay. So let's go ahead and add the column. Now, right now, the formula has VR quarter number equals VR hint new quarter. Let's replace that reference with the variable with the actual number, which should be the number 6. Hey, there we go. It's the number 6. So now we're going to add a column where we say for every single row, check to see if that quarter number is equal to 6. Well, that's pretty easy. All right, let's go ahead and add that. Hey, there we go. And you get a bunch of falses everywhere except on quarter 6, which you might kind of expect, okay? So 1 doesn't equal 6, neither does 2, neither does 3, neither does 4, neither does 5. When we get to quarter 6, sure enough, we get a true, and then we get a false for 7 and 8. So the only row where we get a true is this one right here. So what does the filter iterator do? Well, it only keeps the true rows. It's going to produce a temp table with just those true rows. So I'm going to go ahead and click forward.
One question. There's 2 questions in the chat. I thought it might be good to just quickly pause on.
Sure, yeah. What do you got?
So Ron is saying he's having a little trouble between the connection between quarters and the data and the months you're talking about, you know, with the quarters consisting of 3 months. Ron, I don't know if you want to come off mute and maybe elaborate a little bit more on your question.
Oh, shoot. I'm sorry. This says month right there. That should be quarter. My apologies. Thank you for catching that. That doesn't make any sense. Yes, that's a very good catch. It should be quarters. Yes. It's one of those things that I would have caught if I was paying attention, but apparently I wasn't.
So yeah, previous quarter, following quarter. Yes.
Yeah. So in real life, I always write previous month calculations. I don't tend to write quarter stuff as much, but months wouldn't fit on here, which is why it's quarters. My apologies.
Okay.
Boy.
I think
minor issue.
Confusion.
Okay, sorry about that. So hey, so this is the temp table that filter produced. It's just the true rows, right? And so we're going to store that in that variable right there. There we go. Okay. So now what are we going to do with it? Well, it's right now it's just a temp table and a variable, right? And the filters are, I mean, they're not wrong, but they're not what we want yet. Right now we're looking at Q3 of 2017 because that's what's selected. We want to look at Q2 of 2017. So we have to take this temp table and add it to the filter context. That's where the calculate function comes in. And our next little bit, okay? So for the last bit, the calculate function is going to modify the filters. Revise the filters is the term that I use. It's going to add this as a filter, and then when it's done, it'll run argument 1. Argument 1 is the last thing that runs in calculate, right? So what are we going to do? We're going to go, first we're going to call it VR override new quarters, which is just going to be that temp table right there. That temp table right there. There we go. Okay, so now calculate's going to add this to the filter context. There we go, just like that, right? So now that temp table has been added to the filter context, and we are no longer looking at Q3 of 2017. We are looking at Q2 of 2017. Notice a second ago, we were looking at Q3, and we saw the quarters for Q3 up there and the transactions for Q3. Oops, shoot. And now we're looking at quarter number 2, and we're seeing the transactions for quarter number 2, okay? So the calculate function has added this temp table to the filter context. With that table in the filter context, it could go about running argument 1, its sub-expression, okay? So what are we going to do here? Well, up above here, we took a derivation and passed it into an iterator. Right here, we took a derivation and passed it into an iterator. What are we going to do right here? We're going to take a derivation and pass it into an iterator, right? So the derivation is that right there where we go get all the visible rows of fact sales. Not all the rows. We would need the all function for that. We just want the visible ones. Just want the visible ones. And hey, there's only one visible row right there. That sad transaction. So we go ahead and get that. Now the SumX iterator is going to add a column to it with this definition, its expression column, and it's going to sum up the results. There we go. So we're going to add that to the temp table. And then we're going to sum up the results, right? So the column is for every row, get the quantity multiplied by the price. 4 times 2,000 is 8,000. And if you take the sum of 8,000 and nothing else, what do you get? Why, I believe, I think, I assume, I don't have my calculator on me, but I'm guessing you get 8,000. Sure enough, you get 8,000. Okay. So calculate is, in a second, it's going to return this to the measure, which will return it to the visual, right? But before it can do that, it has to clean up after itself. Calculate's a very good roommate. A second ago, calculate added this temp table to the filter context. Now it has to remove it. So it's going to set the filter back to the way that it found it. And now it can take that $8,000 and it can return that, which then gets passed to the measure, right? And now the measure should read 8,000 and it should look like that. Simple as that. Simple as that. Okay, I'm going to pause for just a second. Any other questions? I don't know how I missed that month thing. Whatever.
There's a lot going on, Brian. Don't beat
There's
yourself.
a lot going on.
There's a lot going on.
Yep.
So there are some questions. There has been some conversation in the chat, which I'm loving to see. You know, there's others in the chat. You know, I see Kurt's got some questions. Ray and Kirill have been helping him out. But I think Kurt's question was more specific. Does anybody have questions on just what Brian shared so far?
I've got another example I could show you too, but I do want to pause if there's quickie questions.
Let's see, I'm scrolling. At first,
yeah, Greg, it's just me. I'm completely dominating the chat. So,
no, you're good. If anybody else, well, Kurt, do you want to just kind of mention what your question was?
Okay, it is related to the timing, but it's actually distinctly separate from your stuff. So I want to give people a chance to ask questions specifically about the stuff that you're doing, and then I'm happy to ask the question.
Sure. Yeah.
While we're waiting for people to chime in, basically, and we've had this conversation before, Brian. Everybody has their one thing that eludes them, and sparse matrices completely elude me. Where I've got a set of tech reps, and I've got a set of issues that they do, and I have to get some sort of throughput dashboard, whether that's going to be an area chart or a line chart or a bar chart, and the list of issues can show up with none on a particular day, and the set of people touching them can have none on a particular day. And I want my bar chart or line chart or whatever I choose to do to be able to show the zeros for their throughput, and getting it to do that, and having slicers that will go across all the people and all the dates is a really simple thing to do in Power BI, but for some reason that eludes me.
So I think, I mean, it could be a longer explanation. The short answer is, if you've got a situation like that, assuming it doesn't make your chart explode, is you just add 0 to whatever your measure is. Because by definition, if a measure doesn't find any numbers when it does its aggregations with its iterator, it'll return blank, and blank rows and columns get excluded or suppressed from the matrix visual. So once you add 0, you should have too much data. It should be, you know, however many reps you got by however many issues you got. Now, that might be too big, but like you should still have the full thing, and then you could use the slicers to sort of whittle it down. But there may be more sophisticated versions than that as well. Don't know.
That's the feedback that I'm getting from Kirill and Ray. Because the other alternative is I just put it into my SQL query as I'm going through with a bunch of outer joins, but I don't really want to eat up all that CPU time refreshing and reloading when Power BI should be able to do this for me much faster and more efficient.
The other option, and it's a quickie, and it won't show zeros, but it'll show blanks, is if you right click on a visual. I don't think this is gonna. No good examples here. If you right click on a visual in Power BI Desktop, one of the. I'm just going to show it to you. This is not going to make any sense if I keep talking about it. Sure, I'll do it in here. In what I call the wedding cake over on the right-hand side, where you've got all the different pills for the different columns that you've got in your visual. If you right-click on any of them, there will be an option for show. How do they phrase it? Show items with no value, I think is the name of it.
Show items with no data. That's the link.
That's literally what Kirill just dropped in the chat.
Oh, yeah. So, yeah, that's the other way to do it. And you know, like it basically works the same way. Some folks are like, I want to see the zeros. But if you don't care about that, save yourself a mouse click and just show items with no data. Yep.
Yeah, thanks, Kirill. That's exactly the kind of thing I'm looking for, because I'm just going to have to go look at a video and have it show me how to do it. Because I can do all the other stuff I want to do. It's not like I'm a complete noob across all the stuff that Power BI does, but this one is just one of those things that grabs me every time I try to do it. So
yeah,
thank you guys.
If that, yeah, try the show items no data. If that doesn't blow up your memory on your load for the visual, then go try to do what Ray did and literally replace nothing with zeros, and that'll increase your data set. But you know, whatever works.
Awesome.
Okay.
Anybody else have questions? I think everybody's still responding to your point, Kurt.
Sorry, I'm not trying to dominate the meeting.
This is all about, as I said, you know, just community sharing, community experience is what everybody's having issues with. So glad you spoke up.
Do we want to see an example with 2 hints, and I'll go through it kind of fast?
If you got more content, Brian, I'm sure nobody's going to say no.
All right. So let's go. I'm going to burn through one here real quick, and I'll go at a faster clip just so you can sort of see how it works, right? And this is a pretty easy one. Okay, so here the only difference is we have 2 hints. So we've got a previous year, which actually this should say previous year. This is quarters in the previous year, right? So if we have Q123 selected, we want to get sales for Q123 of the previous year. Now we can't do 1 hint, so we're going to need 2 hints. What we're going to do is we're going to find what the minimum quarter we're looking at over here is, which is 5, and also the maximum, which is 7. We'll use those 2 hints to build a table of all the quarters 5 through 7. So let's just sort of burn through that real quick. I'm going to go ahead and stop you. And pause. Okay, so we start, the measure goes ahead, and the filters from the slicer are already there. If we were doing this on a table visual, it would add any values of the current row filtering, also known as context transition. And then it could go ahead and do the fun stuff, which is to say our formula. So it's going to start by doing some hints, right? So we're going to go get all the visible rows of dim quarter, which is those quarters right there, the ones that we've got selected, right? That derivation will produce that temp table right there. The min-x iterator is going to add a column to it with that definition and then take the minimum value. So here we go for every single row. For every single row, we get the quarter of that row, 5, 6, 7, and we take the min. The minimum of 5, 6, and 7 is 5, so this should return 5, which is, by the way, the first quarter that we're looking at right now. But we don't want 5, we want that quarter last year. So we take 5 and we subtract 4. There's 4 quarters in a year. And that'll produce our hint, which is the number 1. That's going to be the new starting quarter that we look at. Okay, so now we got that. Let's go ahead and get the new ending quarter. It's going to be the exact same thing. The only difference is that instead of using min-x, we will use a max-x. So just like before, we're going to use this derivation to go get all the dim quarters. Well, there's 1, 2, 3 that are visible right now because of the slicer that we've got selected. So there's all 3 right there, 1, 2, 3. Right? The max x is going to add a column to it with that definition right there. For each row, get that row's quarter, so we should get 5, 6, and 7. Sure enough, we get 5, 6, and 7, and the max x is going to take that expression column and take the maximum value. That's what max x does. Right? That is the x that max x is taking the max of. Right? So 5, 6, and 7 returns 7. That's the biggest value. But 7 is the current biggest quarter for what we've got visible. We want to go get that quarter last year, so we subtract 4 again. 7 minus 4 is 3, last I checked, and we store that in the variable, right? So now that we've got the numbers 1 and 3 stored in those variables, we could go ahead and get the quarters that go from quarter number 1 to quarter number 3, which is what this bit right here does. This bit right here. Okay? So just like before, we're going to do a derivation. Unlike before, though, we're going to get all dim quarter, not just the visible ones. So all of them, 1, 2, 3, 4, 5, 6, 7, 8. There we go. There's all 8 quarters, right? And so now the filter iterator is going to add an expression column with this definition right there, right? Now let's go replace those references to the variables there and there with the actual values. So those become 1 and 3, those numbers right there. So now all we're really asking is we're going to go add a column where we say for every single row, check to see if that row's quarter is both greater than or equal to 1, and that's what that means right there, and less than or equal to 3. So it's got to be between 1 and 3. So 1, we get a true, 2, we get a true, 3, we get a true, and then we get a bunch of falses, right? We're getting all the quarters that are between quarter number 1 and quarter number 3, okay? So what does the filter iterator do with the results? Well, it just keeps true rows. And sure enough, it's just going to bring back those true rows right there. Again, I'm going to go back. We get 1, 2, 3 true rows. Those are the 3 we're going to keep. Filter produces that temp table right there, which, by the way, is all of the quarters, not in 2017, but in 2016. These are all the quarters that we want to look at. Okay. So now, just like before, we're going to squeeze that into a variable. And now we're going to use the calculate function, which is a reviser, to revise the filters before running a sub-expression. So we want to run this after we revise the filters. So the first argument is the last thing that happens in calculate. How do we want to revise the filters? Well, we want to add a filter with this temp table right there, which is that value right there. So let's replace that reference to the variable with the actual temp table. Hey, there we go. Now calculate's going to add it to the filter context. Right now we're looking at Q 1, 2, and 3 of 2017. And right about now, calculate's going to take the temp table and add it as a filter. The previous filter gets overridden, says, no, 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 we now want to look at these quarters. And now that we've got this filter in place, we stop looking at 2017 and look at 2016, Q1, 2, and 3. So now with that filter in place, calculate can go ahead and run argument 1, the thing it's going to run once the filters are changed or revised. What do? Well, again, we do a derivation. We go get all the visible rows of fact sales, right? Since we have the filter set up to look at Q1, 2, and 3 of 2016, it's those transactions right there. We go ahead and get that as a temp table, right? SumX is going to add an expression column with the definition in argument 2. For every single row, take the quantity, multiply it by the price. So we should get 4 times 8,000, 2 times 4,000, 4 times 8,000, et cetera, et cetera. And we do, right? And now the SumX iterator is going to sum up those values right there. That's what SumX does. That is the X that SumX is summing. Okay, so the sum of all those is 101,000, right? Calculate wants to return that before it do. It's going to clean up after itself. Going to pull that filter out of the filter context. We go back to looking at 2017. Now calculate is going to return that number right there, that 101,000, which is going to get sent to the returned keyword. And now this will show up in our card. Just like that. Hey, 101,000. Okay. Great. So that's the second example. I do want to point out very quickly before we open it up to general questions, right, that we've got the 3 elements that I talk about, but the ones I really care about in this particular set of patterns is the derivation and the iterator. The derivation is the thing that gets the temp table. The iterator is the thing that does something with it. So this is that previous year simple calculation that we've seen before, but we're seeing different steps, right? So here we're about to derive dim quarter. Here we're about to derive all of dim quarter. And down here we're about to derive fact sales, right? So even though it's different stuff typed out, the general process is the same. In each one of these steps, we're going to go get a temp table based on tables in the data model, right? So if I go from there to there, they all return a temp table based on the table in the data model. Even though you write different stuff, they do the same kind of thing, which is why we call them all derivations. It's just a name that we give them, right? And once we derive, we almost always pass the results into an iterator, which again, we have 1, 2, 3 examples, but it's the same kind of deal. On each one, the maxx iterator is going to add that column, the filter iterator is going to add that column, and the SumX iterator is going to add that column, just like that, right? So it's different stuff, but it's really the same pattern over and over again, right? And now once we've added the column, the different iterator is going to do different things with them, right? The maxx iterator is going to take the max value. The filter iterator is just going to keep the true rows as a new table, and the SumX iterator is going to sum them up, right? Just like that, okay? So even though there's a lot of stuff going on in this big pattern, really it's just the same simple couple things over and over and over again. And it's amazing how much mileage you could get out of these simple patterns. And with that, I'm going to shut up. You guys have heard enough of me. Okay. So that's kind of it. I could open it up to questions again. And I'll even promote my stuff. Why not? I built this shameless self-promotion slide. Hey, you should go watch the Elements of DAX. It's really good. I hear the guy that did it is pretty good, easy to listen to, right? We talk about all these concepts and more, even further in depth.
I think that's a great note to kind of give a round of applause to before we jump into the questions. If everyone wants to come off mute. Great work, Brian. Thank you so much for sharing this, taking the time to be with everybody today. Then the chat is blowing up. Thank you, everybody. Great question, Brian. What is underneath the hat? It's just your brain, right? Like there's no.
Yeah, unkempt hair, basically. No major tricks up my sleeve. No cooling systems, no nothing like that. No cheat cards. I keep the cheat cards in my like underneath there and underneath there, but I'm not going to show them to you because they're for cheating.
Love it.
Cool.
Well, thanks again, everybody, for just being part of the community, being here at our event today.